change. Like they don't account for so many things in their model to like try to make the three body problem work, and it's like they always do this shit. They just never deal with
Jace
what
ugly and
their model
stupid.
actually.
Why are you bringing?
He's
Why are you
dumb.
bringing
Explaining
me
it
up?
pretty
Why are you
well.
bringing this
Yeah,
old
when does
news
that guy
up?
ever tell the truth about stuff? Oh, hi, Jayace.
Why are you
You guys,
bringing this old news up, man?
you guys want to solve your
We
Why are you
problem?
already
guys
we're
Yeah,
conjuring
last
him
one
now
time
again?
Jayace tried to he tried to tell me why the sky was blue, and that didn't work out so well for him.
That's
That's
some
fine.
old shit, man.
yeah. You can pretend that, but it's fine.
So I can't even remember. What is that? Did that show end, or is it going to be like a season 2?
Hopefully not.
Well, he was explaining it pretty well. Like, I think we need to go back and we need to revisit conservation of momentum and
He was
Coriolis
not
and all these
explaining
other
it
things.
well.
He was. He
Even
was
the
That's what I was
following
trying.
perfectly.
That's what I was
he
trying
had
to do with him, Carl. But he would not let me. Once he realized it was making sense what I was saying, that's when he
No,
derailed the conversation.
don't straw man me. Don't straw man me. If you want to have a conversation again, that's fine.
I don't. I told you I was giving you one last time, and you ruined it, man.
Yeah, but don't just bow out and say that I was doing something that I wasn't doing.
Yeah, that's dishonorable.
I think you should
Yeah, I
calm
mean,
down, man. You just got to take it real slow
He
and
was
be
he
real
was
patient.
trying he was
You'll get
trying
there.
his best. He was doing pretty well. Just like the plane would be pretty much in sync when it's trying to land. Pretty good, as long as it's close.
he got mad that you brought up the back of the truck. Like, wait, why are we in the back of the truck again? And he's like, I just want to stay in the back of the truck. And there was
It
no reason to be in the back of the truck, but he's like, fuck,
really isn't.
I want to be in the
You
truck. We
can
went through
treat
this whole truck thing. Let's stay in the
you can
truck.
treat the earth like a truck. You can treat the earth like the back of a truck. You can, but y'all
There
wouldn't
you
let me
go.
build in the curve. You wouldn't let me
That's
build
because
in
they're
anything
flat.
else. You just
Why don't
derailed
you
it.
just why don't you just use planes in the earth, man? Makes no sense to be in the back of a truck when it's a non sequitur.
It didn't really make.
Because
You got out of the
he
truck, dude, and you still.
Jeremy
It was a little
tried.
weird.
Jeremy tried to build the plane, but he brought up every other variable except staying on topic. I can try
Yeah,
that
but
too. We can try that in a minute. I can
wait,
try that when
listen,
I finish pumping my gas.
there's only one question you need to answer. How does the atmosphere accelerate the plane twice as fast perfectly sideways? How does the atmosphere do that when the winds are blowing in all directions? Just
That is
answer
a
that.
weird question. That is a weird
Well, it's
question.
exactly what would have to happen is the problem for you.
I mean, everything moving with the Earth, weather
Oh,
system,
pretty much, right?
Was the
Do
which
you
truck?
do you
Almost
want
as
me to
if
Was the
try
Earth?
this again with you with an airplane? I'll go get my slushy, and then on the way home, on the drive home, I'll try it again with you with airplanes and Earth.
That's a good
If you want me
Just
idea,
think
to.
about it,
Carl.
man. We're talking about a big metal tube in the air, and it's got to be so perfect that the pilot can just assume it's perfectly stationary. It's a big tube of metal, and you got to
Carl says
name the force that makes it perfectly in sync.
Carl says
Even
he
though
was
that
sticking
big
with it.
tube of metal is pushed by the atmosphere as winds in all directions, it's a conundrum, and you act like there's nothing to worry about. And it's ridiculous and silly and hilarious, actually.
Was the turntable or was the truck the Earth, Carl? Since you were sticking with it, which one was it?
the turntable. So the first thing he was trying to get you to realize is that
Oh, like
the
I don't
orbit around
realize
the
something. That's
sun.
hilarious too.
Well, I'm saying that you don't. So I got a phone call, and I'm not trying
As
to say
long
that.
as it's pretty close, right, Carl? As long as it's pretty
The
close, we're
first
good,
thing
right?
the first thing he was trying to explain was the speed of that the Earth is moving around the sun doesn't matter. Like, don't take that out your head.
I
The only
wasn't
thing
talking
that
about
matters
that.
is
Okay, so the
well, that's why he was
Then you're
talking
just not
about the
understanding
truck.
at all. I wasn't
the
saying
truck was the
anything
orbit.
about the Earth moving around the sun. I was not at all including the idea of the Earth moving around the sun. Where did that come
No,
from? Where did you get that interpretation?
because that's what he was talking about at first when he was talking about the truck going down the street.
No, then you didn't understand him either. It had nothing to do with Earth moving
Yes,
around
I
the sun.
did. That's what he's talking about. When he's talking
No.
about a truck traveling 500 miles per hour down the street and you flying a drone on it, that's equivalent to the Earth moving around the sun. Then when he
No,
put it
we're
on the
talking about Earth
turntable,
rotation. We're talking about the
oh
rotation on
god,
the axis, Carl. We're not talking about
no,
the orbit. No, he's not talking about the orbit either. I guarantee it.
Yo, perspective. Listen to what I'm telling you, Cuddy. When he was talking about the truck driving down the street, he was talking about the Earth going around the sun. When he
No, he
brought it to
wasn't.
the turntable, then he started talking about the rotation of the Earth,
No, you're
about his
wrong.
axis.
That part, yeah, but
Okay.
the first part was also about the axis. He's talking about
No,
the
it wasn't.
Earth's axis. Well, ask him right
No, it
now. Is he
wasn't.
still here? Were you talking about the orbit around the sun? Because then it's really a non sequitur. Because that's not what either of us are talking about, Carl.
RL photography. He could straighten
Yeah, he
it
was trying to hard.
out. Is that what you
If
meant with
that's
the
what he was
truck?
talking,
That was
if
the
he was
orbit.
talking about the orbit around the sun, it makes it even more hilarious. Because that's ridiculous.
Well, yeah, at first he was talking about the orbit around the sun.
Why would that be like what we were talking about? Why would that be anything?
Because you're totally
Because y'all always say that the
confused.
Earth is, yeah, you're super
You're
confused. You're always talking
confused
about we're
about the
spinning, flying.
conservation of energy, man. So he's trying to take it
Conservation of
back.
momentum. I let him beg the question for that all
He's
day.
trying to
500.
take it back
You're a
to the
little late,
base.
Jayace.
He was
You're a
trying
little
to
late,
take.
Jayace.
Dude, stop interrupting, man. You're
500
very
mile per hour
disruptive.
conserve momentum. I
You
totally let him beg the
disrupted
question with
him.
that.
You've disrupted him. You've disrupted Carl. You've disrupted me. Stop being disruptive. Just let us finish. Right? He
Well, you
was
just were coming
mentioning
in
those
late and you
things.
didn't understand it. You didn't
I've been
understand what the
here
whole
the
thing
whole
was.
time. I've been here for
Okay,
an
so
hour.
I allowed the conservation
Stop
of momentum thing.
disrupting. Stop disrupting everyone. It's
I'll
getting
let you complete your
ridiculous.
He has to. He has to.
He was bringing that stuff up because you're not understanding like the basics of the conservation of energy and how it applies to a flight. So he's trying to break it down to like the lowest level that he could for you. That's why he was bringing that up.
Okay, that's your interpretation for real? You good with that? You good with that interpretation?
Yep.
Was the truck the Earth
You
or was the
solid?
turntable the Earth?
You solid with that, J Ace? Are you sure that's what happened?
Perspective. You want to try this again with me? I'm riding home right now.
I just want to know if J Ace is right. Was he right about what he just said?
I don't know. That was y'all's conversation.
Well, he said that
All right.
I was confusing the idea of conservation of energy, or in this case, momentum. Is that the case?
I don't know. It sounded like to me you did not want to hear it. You didn't want to hear that argument. But if you want
Was
to,
the
we
No,
can
it's
truck
not
walk.
true. I'm just saying
If
use
you
the
the
want
earth
to,
and the plane.
turntable the
Why
Earth?
use the
Which one
back of
was
the
it?
truck? He's confusing it
I'm
by using the
Carl's
back of a
confused.
truck.
I'm ready to use the plane and the earth right now.
Perfect.
If
Let's do
Okay,
that.
but
if you want
way back, not that long ago, Carl's still confused. Was the
to.
truck the Earth or was the turntable the Earth?
Oh God, I
The
wasn't
truck.
confused. Hold on, just listen real quick, and then I'm gonna mute back up and let you do
All
this.
right, then I was
Listen,
confused. I might be confused.
yeah, you're
Was
confused.
the
Yeah.
truck the Earth or the turntable the Earth?
Listen, he was trying
Carl,
to get you
wait.
to
Also,
understand that. Listen,
Carl was
I'm
saying
about to
that
tell him
we
what
were
I was
talking about
saying.
the orbit.
I'm trying to tell
RL,
him
were you
what I'm
talking
saying.
about the orbit of the Earth around the sun at any time? Were you talking about the orbit of the Earth around the sun? Just answer that.
Not yet. I was trying to get the
Okay, not yet.
Coriolis.
So no. The answer is no, Carl. He was not talking about the
No,
orbit of
he
the Earth around the
absolutely.
sun at all.
RL. So let me ask RL. RL, when you're talking about the truck going 500 down the street, and you on the truck, and you flying your drone around, that's the equivalent, right, to the Earth going around the sun in movement.
That could be equivalent to that or the rotation around its axis. It doesn't
Was it?
matter
Were
what I
you
was trying to
trying to
get.
say?
Oh, well, shit. Well, I was
RL,
wrong then. Well, I don't know what
what
the fuck
was
you
your
talking about.
point with that?
No. What
Were
I
you
was
talking about the orbit or were you talking about the rotation?
I was talking about rotation at that point. I hadn't
That's what
gotten
I
to
thought. There
the
you go,
orbit yet.
Carl. Are
Oh,
we
well, shit.
happy?
My
Are
bad.
we done with
Yeah,
Carl?
yeah, well,
Are we done with
I was
Carl?
wrong. I was
Okay,
wrong.
Carl.
But
Fine.
he's wrong because that's not a good. If he was using that for rotation, that's not a good example.
Well, that's okay. Yeah, now you guys can have that one out. That'd be funny to hear.
Are you ready to do airplane Earth perspective?
Go ahead, yeah, sir.
Yeah, but
All
is
right.
the airplane going to remain the Earth, or is then you're going to have a turntable in the airplane, and that's going to be the Earth?
I don't know what that means, but anyway, we're gonna start at the very basics and we'll build up. Are you willing to build
All
this
right.
with me? Are you going
let's
to
do it.
jump ahead of me at any point in time?
We're using the Earth in an airplane. Let's do it.
Are you going to jump ahead of me at any point in time?
If I have to clarify, I want to make sure to clarify. But otherwise, I'll try to
How
make
can
sure
you
you get.
clarify going forward? Anyway, let's try this. I'll try it. All right.
So
Let's
basically, you can
pretend
go back to like
we're,
chapter 1.
we're on the spherical Earth. It's huge, and there's an airplane. No wind,
Yep.
no rotation, no movement, no nothing. Just a ball and a plane.
Really?
Can the plane take
Stationary
off and
ball.
land? Yes.
Stationary
Stationary
ball?
ball. Yes.
Well, why don't you just make it flat too then? If we're going to go flat versus ball, does it matter?
You don't want to do this.
No, it can't.
You don't want to.
Then we have. Why make it a ball if it's stationary? That's fine. Okay, yes, it can.
Yeah.
Why make it
If it
flat?
has
Why
the
make
same,
it flat if it's stationary? I thought we were talking
because
about the
that.
Earth here in my
Because it
model.
Why
is.
isn't it spinning?
Oh God, this is
Your model's not
ridiculous.
spinning.
The thing is
God,
that okay,
y'all are
if
weird, man.
if the
Yeah, you
ball had
can't.
the gravity without the spin and it worked all that perfectly fine, I guess the plane could land like it's stationary and treat it stationary and it would be fine. Let's just go with your scenario, as if there's no problem with like accounting for curvature and that doesn't matter. But yeah, let's just say it's
I can't
stationary.
have this conversation. Y'all
What?
can talk. Y'all can.
He was granting you so much there.
I didn't ask him to
Right.
grant me anything but a ball and a plane.
That's
That's
all
it.
you did was preface the entire conversation with, "Are you going to grant me everything the entire way and never
Yeah.
question me once until we get to my conclusion?" You said you kept
How did you
No,
get
it was
begging
that?
him not to jump
I let you
ahead
do
it
or
was
it.
his
whatever. It's like,
scenario.
dude,
That's
he
go
wants to
ahead.
understand. He wants to understand your premise and your logic so he can properly ascertain what you're trying to communicate to him and properly respond to him. And he's been very polite this whole time. You guys are
What?
piling onto him for some
Holy
reason. It's
crap.
weird to listen to.
Did
What?
you ever know that you're my hero?
I don't know what you're
Toby.
laughing about or saying what about, but I'm just sitting and listening
I
myself,
just
and
love when
I'll
Toby.
say right now, New Perspective
I
would have
love.
never given you that normally the floor like he just said, and he gave you the floor and gave you what you asked for, and you still said, "Oh, I can't talk to you." I
No,
got
he
Yeah,
Color
did not.
commentary all the way. Thanks. By the way, thanks,
clarify.
Jace. Thanks, Left Lane. The color commentary was really helpful and really moved the conversation forward, didn't it?
Look,
Thanks, guys.
perspective. All I asked him to give me was a ball and a plane, and he went on some tirade about multiple things I did not ask about. I just asked about a ball and a plane. Can we have those two things?
No, he went on about
You
relative
said can it
motion,
land?
and you wouldn't let him talk about relative motion, even though the
Yeah,
whole
what does that
conversation is
have to do with
literally
the
relative
ball and the
motion.
plane? What does that have to do with a
Hold on,
ball and a
hold on,
plane?
hold on, wait. Let's not argue about the argument. I appreciate your help, guys, but let's just say the plane can land on the ball, even though it doesn't treat it like a ball, but it's stationary. So the plane's treating it stationary. Let's just go with your scenario, and I'll try to walk through it. I know you're trying
Okay,
to understand
perspective.
this, or maybe you think you already understand it. Are you open to possibly not necessarily understanding it, or are you set that you understand it works perfectly?
I'm open to everything. But what I'm
Okay, good.
asking you is, did I ask you about any of that right there, or did I just ask you about a ball and a plane?
Well, you said could the plane land on the ball if it's stationary?
Is that a yes or no question?
Well, the only thing I wanted to clarify was that if it's not if it's a ball and it has to have the gravity work the same way without the spin and all that. But yeah, okay, let's just say it can. Okay, where the ball it's treating it, we're going from different the smaller part of the ball to the outer part of the ball, and it's not spinning at all, right? So what I think you're getting to is that it'd be fine for it to just treat it as stationary in that scenario. We're starting there, right?
Remember when I asked if you're going to jump ahead of me, and you just said, I think you're getting to this. But anyway, gravity works the same. It's a ball. We're at the
Okay,
equator of this ball.
let's go with
The
your scenario.
plane, we're asking if the plane can take off on the equator of the ball and land on the equator of the ball. It's not moving. It's not
So
spinning
yeah,
anything.
yep. Okay, let's say it can. Yep.
That can happen. Okay. Now we put wind on the earth. We got 5 mile
All
an
right.
hour winds, 10 miles an hour winds. Can it take off from the equator and land back on the equator?
Yeah, and just correct, and just if it needs to land in a certain spot, it can be correct for the winds and land on the stationary surface without worrying about much. Yeah.
Okay. Now we start that ball to spinning.
Mm-hmm.
Just like if you spin a ball inside of a bucket outside, you got your paddle spinning up paint. The paint moves with the paddle, right? So the air is going to be in lockstep with this ball, right? We start the
No,
ball to spinning.
do we still have winds going in all directions?
Yes.
Well, then the air is not in lockstep with the ball here.
All right, let's take the winds out for a second. We'll put the winds back, but let's take them out for just 1 second. I take the winds out, spin up this ball, 15 degrees an hour, 1,000 miles an hour at the equator. Is the air now spinning with that ball?
So you're talking about no winds, and it's in such perfect sync that there's no winds whatsoever, right?
For right now, yes. I will put the winds back in just a second.
All right. So we have no winds whatsoever.
Third time, yes.
And we're talking about difference in tangential velocity yet, or no?
What
No,
lab
we
are we
still
in?
need-
What lab was this in?
Reggie's imaginary lab.
Okay,
No, this is
so
good, though.
literally,
This is good, 'cause it's a
literally
good
just
point.
pure imagination.
point,
Got
though.
it.
No, but this
Yes,
is what's
pure
interesting.
imagination.
But this is the scenario that I was trying to draw up from the start, and I'm not trying to change it up on you. But the thing is it's interesting because if it's in lockstep, which we know it isn't because of fluid dynamics, so even the atmosphere, regardless of the winds, is never in perfect sync. But if it happens to be like no winds, that's when they say it would be in like lockstep at that little moment that there was no winds, right? So if you go from the 500 mile per hour conserved momentum and you keep that 500 all day long, Jayace, and you have that 500, and I totally understand that that's conserved momentum, you can't just add an extra 500 to have 1,000 miles per hour eastward tangential velocity, Jayace, and just like think that the atmosphere doubles the plane's speed with no wind.
Yes. Why are
You're
you
just
derailing the conversation?
you're ignoring the conservation. You're ignoring the conservation of energy while the
No, I
plane
said
Wrong
flies.
500.
about every
500 is all it gets,
That
bro.
was so
500.
that was so
Holy
cute. That was so
shit! You're ignoring the conservation of energy while the
I
plane
said
flies.
500. You
You're
get it all day long.
ignoring.
You only
You're
get 500. I
ignoring.
didn't ignore you.
You're
What
ignoring
did I
the
ignore?
conservation of energy while the plane flies. That's what is being
Oh,
left out
wait. There's
here.
more Wait, the conservation of momentum comes from the plane being on the Earth. Yes or no?
Yes, a plane flight is time translational invariant. Thus, the conservation of energy applies throughout the whole flight from when it's on the ground to when it takes off to when it's traveling to when it lands to when it parks at the taxi stand. It applies the whole time. That's what's being left out or not understood, and that's where the problem is arising.
Then please explain that to us, because that's a new one, JA. So you're saying that it has the conserved momentum from being on the Earth at the 500 miles per hour latitude. Now it keeps that 500, right? You want to have that. You want to keep that, right? Now it's going to the 1,000 miles an hour, and then what increases this momentum as it flies to the equator, JA? Exactly, what's the force? What's the mechanism, please?
Planes flying through the air, man. Are you
Okay,
forgetting
so
that
the
it's
winds go the opposite
colliding
direction with the air.
constantly with air molecules? There's something called airspeed, which is one of the most important aspects of a flight, and it's a measure of how fast the plane is going through the air. And so when it's colliding with multiples of Avogadro's number of gas molecules in the atmosphere, there's momentum being exchanged during that process. The conservation of energy still applies the whole time that the flight is in the air.
Okay, so you're saying this conservation of energy increases the plane's sidewards eastward tangential velocity perfectly, so it's in sync with 1,000 miles an hour now, even though the air, which is also the atmosphere, moving the opposite direction as wind, could be pushing it wherever. How does that work, Jayace?
We're not talking about wind. We're just talking about the plane needs air molecules to fly. It's constantly colliding with air molecules. That's how it stays in the air through that process of collisions. Because if it stops colliding with the air molecules, plane won't be able to fly anymore. And while it's
I
colliding with
wouldn't claim
them
that.
as it's flying, it's constantly exchanging momentum with the air molecules. There's multiples, so x equals some multiple times Avogadro's number of gas molecules, which is 6.022 times 10 to the 23rd. The plane is colliding with multiples of those amount of gas particles at a time and exchanging momentum with them as it flies.
Wait, when you say exchanging, Jayace, what do you mean exchanging? Like exchanging the original momentum it had for something else?
That original momentum, say, right, we're just going to simplify it. Say when it leaves the ground, right, the value of the momentum is 500, but at the place that it has to land, the value of the momentum there on the ground is 1000. So throughout the flight, every nanosecond, picosecond that the plane is flying, it's exchanging momentum with the air molecules. And these air molecules are moving faster. They have more momentum than the plane does. And they give the plane momentum as it's flying. So it's constantly, that 500 is constantly increasing as the plane makes its way to where it's going to land, until it has the 1000 value of the momentum where it's going to land, and it lands. It's a
So there's no
constant.
exchange.
The conservation of energy doesn't turn on and off. It's constant throughout the flight.
Okay, so in this concept, it's not really technically an exchange. It's just like it gets more from the air. Is that what you're saying?
Yeah. The air molecules will have a velocity based on their latitude. So it depends on which way the plane is flying, whether the plane has less momentum than the air molecules because the air molecules are going faster, or vice versa. The plane has more momentum than the air molecules, and thus it'll lose momentum as it's flying. It'll give off momentum to the air molecules, right? Because the value of the momentum between the plane in the atmosphere it's conserved. It has to remain conserved. So that it's exchanged between the plane and the air or the atmosphere as the plane flies.
Okay, so the air kind of like knows how much it needs to accelerate the plane and gives it the exact perfect amount.
No.
Okay.
There's just a
what about that?
volume of
What about
air molecules that it flies through, and that volume will equate to the proper amount of energy exchange, or else it wouldn't be conserved, and there would be a big problem.
Right. So these air molecules are pushing the plane eastward an extra twice as fast sideways. Is that what you're saying?
No. I mean,
how does it accelerate?
I don't have the time to get into the specifics of like if
you're
going.
This is important.
What direction? What will happen? Maybe I'm sure another Glober understands how the conservation of energy works and can talk with you about it. I do.
Well, let me ask you one last question.
It might be. Is it the picoseconds?
Wait, hold on, wait, real quick. Hold on, wait. I want to know this, Jayace. One last question from you. Now, the air molecules that are like in the form of wind, does the plane have an exchange with that? Those air molecules going in the opposite direction at all?
Yeah. Any air molecule that hits the plane has an exchange of momentum. But
what's the difference between the air molecules
the
and the
exchange is very small because air molecules are very small. So it takes a large amount, like the airspeed, the air molecules that are contributing to the airspeed throughout the duration of the flight. That's where the majority of the momentum exchange is going to come.
Yeah, that's every.
Well, what's the difference between? Yeah, what's the difference between the air molecules affecting the plane as wind and the air molecules affecting the plane for this momentum that you need?
The ones that are, the volume is orders of magnitudes larger for just the air molecules that are contributing to the airspeed versus the volume of air molecules that are contributing to wind. That number is orders of magnitude lower than the volume that's contributing to the airspeed.
Oh, so this is predictable? Like the winds are predictable? And you know that there's a difference in how it would be? Like the air? I mean, winds aren't predictable, are they?
Sure, that they could be in meteorology, but we're not talking about predicting weather patterns or anything. We're just talking about the number density or the volume.
Oh, so you're saying, okay, there's larger air molecules that are overriding the smaller air
Dear God,
molecules.
no,
Is that what you're saying?
not
Oh,
what I'm
okay.
saying. But there's
Wow, you,
another Glober here that can talk with you about this
yeah,
stuff
I'd run
because
away
I
too if I
gotta
were you.
go.
I would
If
run
he,
away if I were
Oh,
you.
don't
Yeah,
project.
good idea.
Don't project.
no,
Good idea.
he
Come on.
would. Yeah.
I know he's
Well, new
projecting.
perspective makes
I
a
know
good
he
point,
would.
right? Like he's trying to get you to new perspective, trying to get you to quantify it all and how it would all quantify to the full momentum change, right? The change in momentum. That's the whole problem here. The lack of
Yeah,
change in momentum. So that does to me that does kind of seem to be where you're kind of running away is when new perspectives trying to make you get specific about the quantification of it.
exactly.
Nobody's running away, man. This is like kindergarten level stuff. Multiple people have
That's
explained
what
it to
someone running
him.
away would say. They would go to
Multiple
insults about
people.
Right.
kindergarten level, yada
Multiple
yada
people.
yada.
Multiple
Hey,
people. Multiple people
hey,
have
Toby. You know
explained
what?
this to him.
It's actually
It's
it's like
not worth the
kindergarten
time. I
kinematics.
have
I
other
call it
things to do. He's
I
being
would call it
very
kindergarten
disruptive,
kinematics. Actually,
screaming over people. It's not worth it.
I think he ran away from
kindergarten
our
kinematics.
conversation,
The
Doc.
kinematic
He
concept.
ran
I will say,
All right, hey,
Jayace,
yeah,
I
sorry,
compliment.
I did talk over you. I'm sorry. We probably shouldn't keep doing that. New perspective.
I want to give
I
Jayace a compliment. I want to give him a compliment. It's
uh,
a really good attempt at making this kinematic concept seem
new
like it
confused.
actually has some physicality.
Well,
Like
I will
he's
be. I'm
trying to
just going to defend
think of.
myself. If someone's going to start calling
Yeah.
it kindergarten, I mean, it's like, yeah, I might be a little triggered and interject.
Go ahead, Toby. Sorry. Kindergarten kinematics, I'm calling it
Well,
because it's
it's
just a kinematic
disappointing when
concept.
you're trying to get him to get specific, and I point out like, hey,
Yeah.
you're running away when he's trying to make you get specific, and then instead of getting specific, he starts going to calling it kindergarten level and yada. Like, well, okay, are you going to get specific yet or not?
He was
I think it was
specific. I don't
obvious.
know how much more specific he can be. It
No, he
seems
was
like
as
you're just trying to
unspecific as
fight
possible. He was trying to
that
wow you with numbers. Someone's new perspective. You're hot micing real bad, man. Sorry, and I interrupted you. Go ahead, K-Swab.
Oh no, I was done.
All right, sorry, my bad. I'm a little, I don't know, interrupty, I guess today. But yeah, I thought like he was getting down to like really intricate like precision details, but he wasn't getting to the important part, which is when you add those up and quantify it and quantify the momentum change.
Hey Toby, I wanted to make the comment. I was listening like the whole time. The hypothetical, the journey that he was wanting to take us on. I was wanting to try to be the one to be taken on that journey just to see how good I could listen and go along with the hypotheticals and the imagination and stuff like that. Because he was going to bring in curvature and spin and orbit and all this stuff, and I wanted to see if I could successfully get to the end of his deal, and him be like, "Okay, do you get it?" And me say, "Yes, that sounds awesome. It's a story," but then we could take it back to the fact that curvature can't be found anywhere, measured anywhere, and motion hasn't been measured and can't be found. Because in reality, that's the basis, man. No curve, no motion. You can't have a spinning ball in space. So, kind of like, let's get back to reality.
Well, I mean, it's a few things. So the first thing is, as far as curvature goes, curvature is going to be only a factor on